Hey everyone, in this video I'm going to introduce you to the fprintf function, which is used to convert data to text. First, we'll take a look at the input arguments to the function. Then we'll explore the various formatting operators which are used to control the format of the text. Finally, we'll work a couple of example problems together inside of MATLAB. Let's get started. In MATLAB, the fprintf function formats data and either displays the results on the screen or writes the data to a text file. The fprintf function has three types of input arguments. File ID is the file identifier. Format spec specifies the format of output fields using formatting operators. And A1 through AN are one or more numeric or character arrays. Now let's take a look at each of these input arguments independently. First, we'll take a look at file ID. The file identifier is 1 for standard output to the screen, and this is the default. If you do not specify a file identifier, then MATLAB will assume the default value of 1 for output to the screen. 2 is for standard error. And our last option is a file identifier obtained from the MATLAB function fopen. Next, let's take a look at format spec. Format spec specifies the format of the output fields using formatting operators. This is an example of several formatting operators. The important thing to remember is that a formatting operator must start with a %. This is required. And a formatting operator must end with a conversion character. This is also required. The conversion character formats numeric and character data as text. For example, the F here specifies a floating point number with fixed point notation. Now maybe you aren't interested in a floating point number with fixed point notation, and there are quite a few conversion characters to choose from. For example, if you wanted a signed integer base 10, you could do %d or %i as your conversion character. But again, in the example we're looking at today, we've chosen our conversion character as f, which specifies a floating point number with fixed point notation. Now, some conversion characters, but not all, have a subtype. And the subtype prints an octal, decimal, or hexadecimal value. And the subtype must immediately precede the conversion character. So let's take a look at our subtypes. The subtypes are on the left and they're highlighted, and they immediately precede their conversion character. There are two different types of subtypes. First, B specifies double precision, and T specifies single precision. And again, the subtypes immediately precede the conversion character, but as you can see here, not all conversion characters have subtypes. To recap, you must start your formatting operators with a % and end with a conversion character. The remaining formatting operators between the % and the conversion character are optional. So let's take a look at the optional formatting operators. Let's take a look at our first optional formatting operator. Our first optional formatting operator is the identifier. The identifier specifies the order for processing the function input arguments. For example, the 2 in front of the $sign tells MATLAB to format the second input argument in the function call. Next, we have flags. This is our second optional formatting operator. And in our example here, we have a plus sign as our flag. And the plus sign prints a sign character, positive or negative, for any numeric value. Now there are several flags. For example, you can use a 0 to pad to field width with zeros before the value, or you could use a dash or a minus sign to left justify. Now in this case, we used the plus sign, which tells MATLAB to always print a sign character, positive or negative. Next, we have the field width. And the field width specifies the minimum number of characters to print, in this case, 6 characters. After our field width, our next formatting operator is the precision, and the precision specifies the number of digits to the right of the decimal point or the number of significant digits, and this depends on the choice of the conversion character. For example, F and E, those two conversion characters, when we use a precision, the precision specifies the number of digits to the right of the decimal place. For conversion characters G, the precision specifies the number of significant digits. Now, in our example, our conversion character is F, and our precision was 0.2, where the 2 indicates the number of digits to the right of the decimal place. So 2 digits to the right of the decimal place. Finally, format spec can include additional text before a % sign or after a conversion character, and in addition, it can include special characters and spacing. So let's take a look at that. So if you wanted to do a backspace as an example, you would do /b. If you wanted to do a new line, you would do /n. So these are special characters and also spacing that you can include inside of format spec. Our last input argument in our fprintf function is numeric or character arrays specified as scalars, vectors, matrices, or multi-dimensional arrays. In other words, these are the input arguments, the variables that we want to format. Now let's take a look at a whole bunch of examples inside of MATLAB with varying degrees of complexity. Now that we're in MATLAB, let's go ahead and open up a new script file, and we'll begin from there. And to demonstrate the use of the fprintf function, we're going to calculate the area of a sphere and then format that output. So the area of a sphere is a function of its diameter. So let's go ahead and define a diameter, and then we'll calculate the area. The area of a sphere is pi times the diameter squared. And next, we're going to use the fprintf function to format how the area is output to the command window. So we call our function, which is fprintf, open parentheses. Now we have our input arguments, of which there are 3. The first is the file ID or the file identifier, which is 1 if we want to output to the screen. That would be output to the command window. Now, having said that, you actually don't have to specify the file ID if you want to output to the screen. If you leave the file ID off, MATLAB is going to assume the default value of 1. So that is something that is actually optional. Next, we have format spec, which specifies the format of the output using our formatting operators. And that's where we're going to spend almost all of our time inside MATLAB today. So we start with a single quote, and then all formatting operators must begin with a percent sign that is required and must end with a conversion character. So the conversion character we're going to use today is f, that is a floating point number with fixed point notation. Then I'm going to do a single quote again. MATLAB will automatically format this as purple. We're done with format spec. So I'm going to do a comma, and we have our final input argument, which is the variable that we actually want to specify the formatting for. In this case, that is the area. So then I close parentheses, and we will go ahead and save and run our program. So I'm going to save this file as format_data. And when I click save, MATLAB will automatically save and run. And we can see that the area was output to the command window because the file ID was 1. And what we're seeing here is a floating point number with fixed point notation. Now, something that may be kind of obvious at this point is it might not be desirable to output the area and report that number to 6 decimal places. So we can use the precision to change that. So the precision always starts with a dot, and the number that follows the dot indicates either the number of decimal places to the right of the decimal point or the number of significant digits, and which one is dependent upon the conversion character. So for a floating point number with fixed point notation, the f here, if I add a 2, that indicates report to 2 decimal places. So again, the precision begins with the dot, and then the number specifies the number of decimal places or the number of significant digits, pending the value of the conversion character. So now if I click run, we output the area to the command window as a floating point number with fixed point notation and 2 decimal places. Next, let's take a look at adding flags. And we're going to add a flag before our precision formatting operator. And let's do the plus sign. This flag is going to output the sign of our variable every single time. So what that means is if we have a positive number, MATLAB will output a plus sign. And if we have a negative number, MATLAB will output a minus sign. So we'll give this a run, and we can see that yes, our area is a positive number, and MATLAB has output a plus sign. Next, let's take a look at the field width formatting operator, and we're going to add a field width after the flag. And let's specify a field width of, let's say, 10. What this means is the field width of 10 tells MATLAB to output 10 characters to the screen. So let's see what that looks like. I'm going to click run here, and the display is a little bit weird, but here's why. So when we look at the number of characters output to the screen, the field width was 10. And here's how you can see that. We have 1 character, 2, 3, 4, 5, and 6. So that is 6 characters, but we specified 10. So we have 7, 8, 9, and 10. And that is the field width that we've specified. Another cool thing about the fprintf function is you can add text before the percent sign in format spec or after the conversion character, and that text can include spacing and symbols. So for example, before the percent sign in format spec, we could say the area of the sphere is, and then what MATLAB sees here is the percent sign, which indicates to insert this variable at that location. and then we control the format of the output of that variable using these formatting operators. So let's give that a run, and we see the area of the sphere is, then we have 10 characters specified by the field width. We have a plus sign because this is a positive number specified by the flag. We have 2 decimal places reported as specified by the precision. Now, in this case, let's go ahead and remove this field width because that output is a little bit weird with 10 characters. So I removed the 10, that was the field width. I'll give the program a run, and this is starting to look pretty good. Next, another useful thing about the fprintf function is you can also control spacing. So for example, maybe I want to start a new line after I output the value of our area. And to do that, you can do a backslash and then n for new line. And what you're going to see here when we run our program is we've started a new line, and you can really see this because our command window input has moved down a line, and that's pretty useful. The last thing we're going to take a look at is outputting the value of more than one variable. And to do that, we really need to do 2 separate things. One is to add another variable as an input in the function call, and the second is to add more formatting operators. So let's do that. So maybe we want to say that the area of the sphere with a diameter of 2 is XYZ. So let's do that. So the area of the sphere with a diameter of, okay, now we want MATLAB to insert the diameter. So we're going to do the percent sign to tell MATLAB to insert your variable here. And then we're going to specify how MATLAB formats that variable using our formatting operators. So let's do something pretty easy. Our diameter is 2, so maybe we have MATLAB format this as an integer, and the conversion character for an integer is just I. All right, so here's what MATLAB is doing. It gets to format spec, and we're outputting text before the percent sign. So we have the area of the sphere with a diameter of. Now MATLAB needs to insert the diameter here and then format it. And we've specified the format using just a conversion character in this case. Then we have we have some more text, which is fine. And then MATLAB sees a second percentage sign, which means insert another variable here. Now for our second variable, which is the area, we're doing more complex formatting. But what we need to do is to add the diameter as our input in the function call. We now have 2 variables that we're going to specify the formatting of. So I'm going to add the diameter here. Now we have 2 input arguments in the function call to format. And I will give this program a run, and we see the area of the sphere with a diameter of 2 is 12.57, and that's looking pretty good. Now the final thing we want to take a look at is the identifier. This is another formatting operator. And to do this, I'm going to purposely make this statement incorrect. So what I'm going to do is I'm going to swap the area and the diameter, and here is why. MATLAB is going to work in order. So our first input argument is going to be format first, and our second input argument is going to be format second. So by default, MATLAB is going to work from left to right, if you will. But what if I accidentally swapped the area and the diameter? All right, so now when I run this, we see the area of the sphere with a diameter of, okay, wait a minute, something's wrong now. And that's because I'm trying to output the diameter, but what I'm actually seeing is the area, and vice versa at the end here. So that's a little bit of a problem, but it actually can be remedied using identifiers. And this is our last formatting operator that we're going to take a look at. All right, so to specify an identifier, you add a $sign, and the number in front of the $sign tells you which input variable to select. So in this case, the diameter is the second input argument in our function call, and so I need to add a 2 in front of that $sign. Okay, so the number always goes before the $sign in the identifier. So again, MATLAB says with a diameter of, it sees the % and knows to insert a variable, and the identifier tells MATLAB which variable to insert, and in this case, it's the second one. So we will do the same thing for our area, but in this case, we are going to do a 1, then the $sign. Because the area is our first input argument in the function call, and this should swap us back to our original order. So let's give our program a run and see if it works. The area of the sphere with a diameter of 2 is 12.57, and that worked out great. All right, y'all, I hope this video provided you with a great introduction to the fprintf function and the use of formatting operators. Thanks for watching. If you liked this video and would like to see more, subscribe below. If you would like to support the channel, consider becoming a member on Patreon or check out some of the Spartan Professor merchandise available on Teespring. You can find me at David Calamus on Twitter, Instagram, and LinkedIn.